Dear friends, welcome to the Sharpage update. I am Deepak Tiwari. Friends, as you know, in previous video I have explained you what are complex numbers. And now in this video I am explaining you how we can represent a complex number on a plane. For this, it means for representation of a complex number on a plane, first of all, we have to know that what is complex plane. So friends, the plane whose every point represents a unique complex number is known as complex plane. Remember, complex plane is also known as Argand plane or Gaussian plane. And friends, the diagram which represents a complex number on a plane is known as Argand diagram. And for representation of a complex number, suppose a complex number we have z equal to x plus I y. And we are representing this complex number on a complex plane. So first of all, we have to draw two perpendicular axes, that is x, O and x dash, y, O and y dash. Here in this diagram, x, O, x dash and y, O, y dash are two mutually perpendicular axes. X, O, x dash is known as real axis and y, O, y dash is known as imaginary axis. X, O, x dash is real axis and y, O, y dash is imaginary axis. In this complex number, x is a real part and y is imaginary part. So, x, the value of x is represented on the axis of x, O, x dash and the value of y represents on the axis of y, O, y dash. Suppose we have to draw a complex number z equal to 3 minus 4i on a complex plane. In this complex number, real part is 3 and imaginary part is minus 4. So, for represent this complex number on a complex plane, first of all we have to draw two mutually perpendicular axes x, O, x dash and y, O, y dash. Here, x, O, x dash is real axis, y, O, y dash is an imaginary axis. So, the distance 3 lies on this distance. Suppose OA is at the distance, F is at the distance of 3. So OA represents real part, but imaginary part is negative. So this will lie on the OY dash in this direction. So from A, the point P lies at the distance of 4. It means point P lies at the distance of 4 from x, O, x dash, or point P represents a complex number that is z equal to 3 minus 4i. So point P is the complex number 3 minus 4. Now friends, any complex number is represented in the polar form of. A complex number is represented in the polar form as, suppose, a complex number is z equal to x plus iy. So this number can be represented in the polar form also, and the polar form of any complex number x plus iy equal to r cos theta plus I sin theta. Here R equal to modulus. Here R is modulus or absolute value and theta is amplitude or argument of the complex number in polar form. So friends, for converting this complex number in the polar form, first of all, we have to know what is modulus or absolute value and what do you mean by amplitude or argument. Suppose this complex number is represented by point P on any complex plane this point represents the complex number x plus iy. So this is the distance x, this is the distance y. Here, by joining the point P to point O, let this distance is represented by r. So in this diagram, the distance between point P and the origin is known as the modulus of the complex number, means r, represented by the distance OP. And by this diagram, we can find the value of r. It means r equal to the square root of OA square plus AP square. OA square plus AP square. So, by substituting the value of OA and AP, we get x square, OA, x square, and AP, y. AP square means y square. So, r equal to x square plus y square. It means the modulus of any complex number represented by this equal to modulus of x plus iy equal to the square root of x square plus y square. And the angle made by OP with the positive direction of x-axis, it means theta. Here, the measure of angle XOP is known as the amplitude or argument of the complex number in the polar form. Means here angle XOP equal to theta is amplitude or argument of this complex number. Now, I am explaining here how can we change a complex number in the polar form. But first of all, we have to find the value of modulus and amplitude or absolute value or argument. So friends, here we are studying some different cases for finding the argument of any complex number. As we know that argument of any complex number is tan inverse y upon x. First case, if x is greater than 0 and y is greater than 0 in complex number z equal to x plus iy. In this case, since x is greater than 0 and y is greater than 0, so point P representing this complex number will lie in the first quadrant. Let, in this case, point P is here. So, here the argument of this complex number in this case will be theta equal to alpha. Here, alpha is the acute angle which OP makes with x-axis. It means in this case theta equal to alpha, means argument of z is theta equal to alpha. Now second case, if x is less than 0 and y is greater than 0. In this case, since x is less than 0 and y is greater than 0, so the point P representing the complex number z equal to x plus iy will lie in the second quadrant of this argand plane. And let point P is here in second quadrant. And let OP makes an acute angle with this axis. So in this case, it means when x is less than 0 and y is greater than 0, the argument means the angle which makes the line OP with the positive direction of x is this angle. And this angle is known as the argument theta of this complex number in this case. And this angle, you can see here, theta equal to pi minus alpha. Pi is the straight angle. इस angle को आपने यहाँ से निकाला. So we get the argument theta equal to pi minus alpha. Means in this case, when x is less than 0 and y is greater than 0, the argument of complex number z theta equal to pi minus alpha. Now, in next case, when x is less than 0 and y is less than 0. In this case, you can see x is negative, y is also negative. So, the point P representing this complex number will lie in the third quadrant of the argand plane. In this way, x O x dash y O y dash. X is negative, y is also negative. So the point P representing this complex number will lie in this quadrant. It means in third quadrant. Let the angle, acute angle is alpha. OP is the modulus of this complex number. Now in this case, the argument or amplitude of the complex number z equal to x plus iy is represented by this angle. Means theta. Here in this case, theta equal to minus pi minus alpha. It means when x is less than 0 and y is less than 0, the argument of this complex number will be represented by argument of z theta equal to minus pi minus alpha. And the last case, it means the fourth case, when x is greater than 0 and y is less than 0. X is greater than 0 and y is less than 0. So in this case, suppose x O x dash y O y dash. Here you can see x is greater than 0, it means x is positive, y is less than 0, it means y is negative. So this complex number means x and y will lie in the fourth quadrant of this ordered plane. It means in this way. Here point P represents a complex number z in this case when x is greater than 0 and y is less than 0, and that the acute angle is alpha. So in this case, the argument of the complex number z equal to x plus iy will theta equal to minus alpha. Theta equal to minus alpha. So argument of the complex number z in this case will represented by this. In this case, the argument is represented by this, and here the argument of complex number is represented by this, and in this case the argument of complex number is represented by this. So these are the four cases for finding the amplitude of any complex number. Now friends, here I am giving two problems. Find modulus and argument of the following complex number. First, z equal to minus 3 plus root 3i. Second, z equal to minus 2 minus I. So try solve these two problems. Till then, goodbye. Please like and subscribe the Sharpage update for the more content related to the complex number